Solving equations using U-substitution is a very, very important topic in pre-calculus because it sets us up for one of the big topics in calculus. This can also be known as solving quadratic-like equations. So we can kind of see what the steps are going to be here to solve by U-substitution. But I want to start by doing an example of why we do this. So U-substitution, remember, a quadratic equation is of the form ax squared plus bx plus c, but it doesn't always have to be an x. It basically just means constant something squared plus constant same thing plus constant, right? So it's in this form, but it doesn't always have to be the letter x. Well, if you can sort of squint your eyes and look at something and see that it has that same a something squared plus b something plus c form, then it is what we call quadratic like. We can see that in this first example. The something here is x plus 2. So we have x plus 2 squared plus 11x plus 2 minus 12. So it's in that same sort of pattern of a quadratic, but instead of x, we have x plus 2. So to do U-substitution, like if I wanted to factor this looking at it the way it looks really ugly and I'd have to FOIL, and we're going to try a different approach to get the answers out of this one. What we're going to do is think ax squared plus bx plus c, and that thing that's sitting next to the b or sitting next to that b coefficient, that is going to become what we call u. So we're going to let u be x plus 2. And then we're going to just double check. If u is equal to x plus 2, what is u squared equal? So we'll set u equal to x plus 2 and we'll square both sides and see what is u squared equal to? Well, that's x plus 2 squared. Well, do you notice that we have an x plus 2 and an x plus 2 squared in our original question? So what we're going to do is we're going to replace the x plus 2 and the x plus 2 squared with the letter u. So this will be u squared plus 11u minus 12. Because we have decided that u will equal x plus 2, so we can substitute there, and that u squared will then have to be x plus 2 squared, so we'll substitute that there. And we get this equation. Now, when I look at this equation, I go, oh, I know how to factor that. What two things multiply to negative 12 and add to positive 1? Well, that's going to be u plus 12 and u minus 1. So remember, we've got that variable u is the variable that we're working with here, right? 12 times negative 1 is negative 12. 12 plus 1 is 11, and we've got the u. Now, solving, we would say then that u is going to equal, when we set each of these equal to 0, u will equal negative 12, and u will equal positive 1. Okay, have we finished solving the problem? Well, no. What was the original variable that we were asked to solve for? X. And what have we solved for so far? U. And this is where I tell my students, because a lot of students get here and they stop because they're like, I have an answer. That's not the answer we were looking for, though. So, what I like to say is don't forget when you're doing U substitution, it's not all about you. My favorite math joke of the year. But it isn't. It's not all about you. Remember, it's not all about you. It's actually about x. So what was u at the very beginning? U is equal to x plus 2. So what we need to do is put the x plus 2 back in for the letter u, the variable u, and then solve. So we'll get x is equal to negative 14 and x is equal to negative 1. Those are our final two answers. Those are the basics of how you solve a quadratic-like formula. So let's kind of run back over our steps. Define the new variable u. Usually it's the thing sitting next to what we would think of as the b number. Substitute into the expression to make sure that what you have is next to the a number is the u squared. Go ahead and do the substitution, factor the new equation. But then remember, it's not all about u, it's about x. So then we need to put back in the x equation and solve for x.